So now let's switch gears completely. We've got a physicist who's actually a cosmologist. Any physics fans here? Yes, I knew there were a couple. And he's a cosmologist. He's also visiting us from Richmond, Virginia. And so with the Higgs boson being in the news so much, he's not going to actually talk about the Higgs, but he thought it was like a little bit of a springboard to talk about a topic in physics, which most of us probably don't know much about, and it's about interactivity and symmetry. So please help me welcome Matthew Francis.
Thank you. Yeah, the Higgs boson's kind of hoggy of the limelight. It really has dominated the news about physics. And that's not to say it isn't important, but it's actually one example of a kind of a general principle in physics. And you probably have read about this, but let me summarize it really quickly. Basically, if you had a universe that contained an electron and nothing else, that electron wouldn't have mass. Now, of course, you can't have a universe with just one electron. That's not the universe we have. But the real universe, the electron acquires its mass through interaction with this Higgs field. And the Higgs boson is what happens if you give the Higgs field a huge amount of energy to pop one into existence. So you kind of have to force those things into existence, but the Higgs field is all around us. Well, most of the mass in your body isn't electrons. It's, anybody know what it is? Neutrons and protons, which are made of quarks. But guess what? It's not the mass from the quarks either. The quarks get their mass from interaction as well. And it's not the Higgs field. It's something called the quantum chromodynamics field. How's that for a mouthful? Because when they were running out of ideas in the 60s and taking a lot of drugs, they decided to call it the color force. You're not going to see the color force in your daily life because it is very short-ranged. But the thing is, without that force, you would not have the protons and neutrons that make up most of the mass of your body. And now this may seem like a non sequitur, but I'm working currently on a book on cosmology. And part of the book is I've been going to actually the first leg of the book I went to Fermilab and a place in northern Minnesota, almost at the Canadian border, called the Sudan Mine, where there is a set of other particle experiments. And you might think it's very strange to be talking about cosmology and going to these particle detectors. But the thing is, cosmology is one of those areas that connects the very smallest to the very largest. And one of the things that you discover when you begin learning about this and begin talking about it and writing about it is that patterns emerge. Just as an electron does not have an inherent mass, it comes out of interactions. And quarks do not have intrinsic mass, they come out of interactions. These patterns emerge from the interactions. And so the structure of the universe that we see, these beautiful pictures. The most recent thing came out last week, a map of millions of galaxies called BOSS, the Baryon Oscillation, Baryon Oscillation, now I can't remember what the second S is.
It's an awesome acronym, though.
Yes, it is. It is very much a BOSS acronym. But now it's going to bug me until I remember what the second S is. But anyway, survey is the other S. But you can go to the web and look at this animation where you're zooming through. But the thing is, these galaxies are, although they are in a certain sense randomly distributed, they structure based on their interaction, their gravitational interaction. And so interaction is what connects all of these things. These patterns emerge out of connections. And so as I've been working on the book and as I've been thinking and writing and talking about it, we realize, how much this plays an essential part. Physicists, we tend to be kind of reductionist. We go to the fundamental laws, but even with that, even with trying to find the basic laws that govern everything, there's behavior that emerges that is not inherent in those fundamental laws. And so, to quote one of my favorite bands, the Decemberists, we are bound by symmetry. Thank you.
Matthew Francis. So you can't explain all my behavior. Some of it is just emergent behavior. Yeah. Especially mine in particular. Matthew, is not my, if protons and neutrons make up most of my mass, is there no dark matter making up, like it makes up whatever 60, not in me? Maybe my dark matter's over there. It's separated from me.